Now, students, we are going to discuss the formation of stationary waves in closed pipe. So before going for the formation of the stationary waves in the closed pipe, you should know what are stationary waves. As already I said, while discussing the formation of stationary waves in open pipe, stationary waves means two waves must be there, and they should have the same frequency and same amplitude. They must travel in the opposite direction and superimpose with each other. The resultant wave we are calling it as a stationary wave. And what is an open pipe we have seen. Now we are going to see what is the closed pipe. So for that closed pipe, what is a closed pipe? Closed pipe means here we can have one side open, another side is closed. And you know, always open pipe means we have two ends open, but here the closed pipe means one side open, other side should be closed. For example, you can see here, this is the situation like this is like this. So here you can see this is one side is open. You can see clearly this is one side is open, another side is closed. So such type of pipe we are calling it as an closed pipe. And always node is formed here. Node is formed at the closed end, and antinodes are formed at the open end. Antinodes are always formed at the open end. So students, what I was saying, so here यहाँ पे हमारे को मिलेगा हर वक्त node और यहाँ पे मिलने वाला है antinode. Beta, let us see actual definition here on the board. What we have, a closed pipe consists of one closed and the other open end. In a closed pipe, always a node is formed at closed end and an antinode is formed at the open end. So this what I have said you. The same thing you have to remember. So here for this, what I do, I start with the first harmonic, that is first harmonic fundamental frequency or the first harmonic in this situation also. So how to move with that? So first I'm writing fundamental frequency. Or this is also called as first harmonic. So under this situation, what we consider, this you can see clearly, this is the AB is the tube, the length is L. Now antinodes are formed means let us make the antinodes here. So here you can see clearly, this is one antinode, I can say this is an antinode, the complete this situation we call it as an antinode, and here we call it as a node. Now in terms of wavelength, if you want to mention the length of the pipe, so it is just half of the loop. Half of the loop. For the complete loop, it is lambda by 2. And for half of the loop means half of lambda by 2, that gives us lambda by 4. So here, in terms of wavelength, I will write this as lambda by 4. Try to understand, this is lambda by 4, but because it is the first harmonic, I will take it as lambda 1 by 4. So the same process what we have done for formation of stationary waves in open pipe. So let us move with that. So here I take AB, or first we mention how many nodes and antinodes are formed. So here you can see clearly one antinode and one node is formed. So I'll write the first harmonic. In first harmonic, one node and one antinode are formed. One node and one antinode are formed. Okay, now let us go with the same process, that is AB is equals to L. The length of the pipe is L, that is we are denoting by AB, but this AB in terms of the wavelength, I can say it is lambda 1 by 4. So this is lambda 1 by 4 is equals to L. So lambda 1, just you can see this cross multiply, it is 4L. Now the same process, we know that what we are getting, V is equals to F lambda. I'll write F1 lambda 1, and here what is F1? F1 is V by lambda 1. So this is F1 V by, what is this lambda 1? It is 4L. So I will write it as 4L. So this is the fundamental frequency what we have in a closed pipe. Hope you have understood this part. Next, let us go for the another situation what we are going to get. See, here we are going to get third harmonic, or we are going to get this is the first overtone. Third harmonic or the first overtone. Now, students, why we are getting this third harmonic and why we are calling it as the first overtone? In an open pipe, always all the harmonics, all the overtones are present. But in the closed pipe, only odd harmonics are present. Even harmonics are absent here. That means we are going to get the first harmonic, then immediately we are going to get the third one, then immediately we are going to get fifth, seventh, like that. So you have to remember the one thing, in an open pipe, we are going to get all the harmonics, but in the closed pipe, we are going to get only what I can say the odd harmonics. Okay, so I'm writing third harmonic, that is also called as, because it is higher, so therefore we are calling it as the first overtone. Okay, now let us move with this. The next situation what we can have here is, this is over already. Now let us form, because at the close end always what I can say node is formed here. You can see we have to get here node. So this is one node, this is another node, and this is antinode, this is also an antinode. Now if I consider this is AB and this is the length of the pipe as L, so length of the pipe as L, but in terms of the wavelength, if I want to express, you can see this is half loop, that is lambda by 4. This is the complete loop, that is I can say lambda by 2. Because it is a third harmonic, what I do here is, here I will take here lambda 3, because third harmonic, by 4, and for this I will take lambda 3 by 2. So from here to here it is lambda 3 by 2, and from here to here it is lambda 3 by 4. So in this, how to mention and what to mention. So in third harmonic, how many notes and how many antinodes are formed? So you can see clearly two notes are there, two antinodes are there, that we are going to mention. Two notes and two antinodes are formed. Now again the same process what we have done here, the same process, that is we can say AB is equals to L. What is this AB? What is this AB? You can write in terms of wavelength lambda 3 by 4 plus lambda 3 by 2, that is equal to L. Hope you have understood what I am doing here. I am expressing the length of the tube in terms of the wavelength that I have written. Now just you take the LCM. LCM is 4. So here it is lambda 3, and you can divide by that 2, that is 4 divided by 2, that means 2 you are getting. So 2 lambda 3, that is equals to L. 3 lambda 3 by 4 is equals to L. So lambda 3, what I am getting it as 4L by 3. Now we start again the same process, that is velocity is equals to frequency into wavelength. So we know that velocity is equals to frequency into wavelength. Because of the third harmonic, I'm writing it as F3 lambda 3. So F3 is V by lambda 3. So F3, this is V. What is lambda 3? Lambda 3, you can see here it is 4L by 3. So that only I'm writing 4L by 3. Now this 3 will go up. So F3 is equals to, this is 3 times V by 4L. Now you can see, students, clearly what is V by 4L. V by 4L is F1. So therefore I'm expressing this F3 as this is what 3 and this is what F1. So that means the third harmonic is thrice the fundamental frequency, I can say. Now let us go for the final derivation part, that is the third one, fifth harmonic. And this is also called as the second overtone. So the possible diagram for this, we can draw. So this is the first situation already we have completed. And this is the second situation. This is also completed. Now the third one, we need to go with this like this. And here the close end is there. So again, I take this is A and this is B. The length of the pipe is L. Now, how many nodes? 1, 2, and 3. 3 nodes are there. And this is one antinode I can consider. This is a second antinode. And this is the third antinode. The situation, complete situation, we are calling it as an antinode. This is an antinode. This is also an antinode. So in this situation, you can clearly see 3 nodes are formed, and at the same time 3 antinodes are formed. Now let us see how to express the length of the pipe in terms of the wavelength. As I told you, half of the loop means it is lambda by 4, and complete loop means it is lambda by 2. So we go for this situation. Here I'll write lambda by 4. Because it is the fifth harmonic, I will write it is lambda 5. This is the complete loop, so therefore it is lambda 5 by 2. This is also complete loop, so I'll write lambda 5 by 2. Lambda 5 by 2. So what we can write, the first point here is how many nodes and how many antinodes are formed. So I'll write in fifth harmonic, three nodes and 3 antinodes are formed. And let us express this AB as the length of the pipe, L. So this is AB. So we can write this as lambda 5 by 4 plus lambda 5 by 2 plus lambda 5 by 4, and that is equals to L. Now students, if you take the LCM here in this situation, it is 4, and by taking LCM 4, what is the term we are going to get? Let us see. So here 4 is the LCM. This is lambda 5 plus this is 2 lambda 2, and this is what lambda 5 is equals to L. So 5 lambda 5 by 4 is equals to L. So lambda 5, we are getting it as 4L by 5. Now the same process we can move with this. What we are going to get, let us see. We have V is equals to F lambda, and here we can write this is lambda F5 and lambda 5. So F5 we can write it as V by lambda 5, and this F5 is equals to V. What is lambda 5? 4L by 5. 4L by 5. So what happens, you know, student, this 5 will go up. So therefore, this is F5 is equals to 5 times V by 4L. Now, what is V by 4L? This V by 4L already we have derived it to be F1. That is the fundamental frequency. So therefore, I will write this as 5 times of F1. 5 times of F1. So the very important and the conclusion point here, again, we need to write how we have written for the open pipe. So ratio of the frequencies in this situation, we are getting here 1 times of V by 4L. Here it is 3 times of V by 4L. And here you can see it is 5 times of V by 4L. So the ratio of the frequencies under this situation, it is 1:3, 3:5, and so on. Only we are going to get the odd harmonics. We are not going to get any even harmonics in this situation. So the same conclusion I'm writing, the ratio of frequencies. The ratio of frequencies is equals to 1:3, 3:5, and so on. So I hope you have understood how to derive the expressions for the fundamental frequencies, that is the first harmonic, third harmonic, and the fifth harmonic in case of a closed pipe, and the conclusion what we are getting. Thank you.